thank you all for coming. I also want to thank WCAU and our host, Amador Vasquez. We had this meeting here last year. Was well attended and well attended this year. This is probably the last time we're going to be here, right?
Yeah. This year I mean it.
Because they're moving into the new building. So good luck with the move. I would like to make a few announcemements. I want to thank myself for the refreshments.
Thank you,
for Everts. So Everts paid for them. I also want to thank all four speakers. They invested some time. We have John Fox from PCN. We have Karl Kuhn from Tektronix. And Tony here at CAU as the Director of Engineering. And we're waiting for Pete Putman from what's the Rome Consultants. Sorry, thank you. So just some chapter news. Hopefully you can reach out and get some more members. We have we've just SMPTE has ratified the SMPTE 2110. This is what we're all about. The networking. I did have quite a few students sign up for this event, but they didn't make it, I guess. Oh, we have. All right, Steve. Oh, Steve. Okay, great. So, if you have any interest and want to become a member, you can send me an email. In this fall, we're going to have a chapter meeting at Newman College or University outside of Philly. They have quite an infrastructure of IP production system down there. So hopefully you'll all attend that.
And do your renewal or membership before the rates go up.
There you go. So I'm filling in for Dover tonight, so I'm going to hand off the program to Mark Mullen from Millersville University. He's going to run this meeting. He's got questions for the presenters. And so we don't delay. Here's Mark. Thanks.
Thanks, everybody, for coming out. Appreciate it. NAB this year, a lot about IP infrastructure, live, over the top, direct-to-consumer, live streams, and all the tools that help you implement it. And there's a lot more than that, but that was a kind of a push towards it. IP technology is taking off. It's something that's been a standard, in the business world. But on the video world, why not go to it? Let's invest in something that's already there. There's a cost savings to it. There's economies of scale. So there's a lot of things pointing to it. And you'll see, we're talking about a couple of things tonight about that. Like going from satellite, instead of broadcasting and uploading a satellite signal, why not send it via IP? We've been doing for years, bringing down, this satellite, the satellite feeds via IP. Hey, Pete.
Other victim of the school kill.
Yep. No, Pete's finally with us here. Traffic. So traditional broadcast methods are being replaced. It's not me to you, and I'm not, getting any response from you. It's going to be a whole new world here, and we're just starting it. We're endeavoring into, what is going to be, and with a lot of new standards. The SMPTE 2110 that Karl's going to talk about a little bit. There's a lot of new things going on. I'm going to start off with John now. NAB's main topic this year, was IP-based products. Technology and cost factors, have approved. All the IP technologies are out there. They provide, attractive, reliable alternative to satellite transmissions. First question I have for you is, what benefits have you discovered using IP-based streaming versus the traditional satellite uplinks?
Well, primarily it's cost savings. We're saving a lot of money with the internet IP. Also, we find the video flow system that we put in to replace our satellite transmission is bidirectional. We have remote management and more variety of encoding options that we can send to our cable partners as well.
Okay. Second question. There are other, I mean, you mentioned video flow. There's other products out there too. Let's see here. High Vision has a product. LTN has a product. Zixi. You know, what elements of their global IP transmission ecosystem are used or most beneficial in Pennsylvania? I mean, it's such a wide, vast area. I mean, there's some places that are, you know, great. You're in a city, it's great internet. There's other places that are geographically separated, and you know, in the middle of a valley, it's hard to get, you know, internet to them. Right. So, you know, what are the different things that you've seen, that you've used, and you looked at NAB that are beneficial? So
we use a little bit of everything. LTN, we have a connection to LTN for our Pittsburgh bureau. So LTN is really a managed private network. They use the public internet to get access to their network. But we use that for real-time video from our Pittsburgh bureau. We also use Zixi. Zixi started out as a software company for forward error correction, for compensating for the internet, and we use them sometimes for backup to our microwave transmission when we do live sports. Or if we're in a hotel somewhere and we want to do a live event from there, we'll use a Zixi encoder to get back to the station. And then video flow is the system that we chose to replace our satellite transmission, which has 28 cable systems connected to it at the moment.
All right, thanks. Karl, I'm going to move on to you. SMPTE, the ST2110, is a multi-part standard suite aimed at standardizing media, you know, over managed IP networks. Kind of what John and many others are using it for. As we kind of transition from the traditional SDI, you know, over coax cable to an IP workflow with the packets, you know, the SMPTE 21 standard, you know, it's helping manufacturers realize, you know, solutions to deploy a new IP media experience. So, what solutions did you see at NAB that impacted you the most and that you thought took advantage of the opportunities available with the ST2110?
Well, at NAB, I guess the reality is the reality of 2110. We have that nice poster up there, so I would recommend, if you haven't been studying what 2110 is all about, do a lot of self-study, because it's definitely, momentum is there, it's reality in the industry. And what really impressed me at NAB was the IP showcase, where 50, 60 vendors is probably up to now, had essentially a live plug fest, an interop going on, where they showed their gear connected to everyone else's gear and actually moving signals around. So what's happening around the country and occasionally around the world, these interops and plug fests are happening at specific locations, like Fox Sports in Texas is one of the nice hosts that we have. But the fact of it is, it's reality now. Where 2 years ago, everybody said it's going to be AIM, is it going to be Aspen, is it going to be 22-6 or -7? Well, the reality is 2110. So I think the fact is that all the users, the manufacturers, have something to grab a hold onto that they can actually develop and produce products. And with that said, that means everyone in this room, unless you're looking at retirement in the next 6 months or a year or 18 months, at some point it's going to be part of your career. And I've had actually people telling me, you know what, it's time for me to retire. And if that's the case, congratulations, good for you, you've earned it. I mean, I've been involved in this industry since I was in 9th grade, and there's a lot of changes going on. But that means opportunity for students or anyone who realizes they've got a long way to go before retirement's a reality. So embrace it, jump into it, learn as much as you can, ask questions. We have resources on the internet. I mean, go to manufacturers and see what they have, download PDFs, and dig into it. But the fact that the interop was so robust, it's to the point that there's so many manufacturers involved, there's almost not room to make everybody fit into the same facility anymore. So with that said, anyone who is looking where they're going to next in a facility, you have to consider 2110. With that said, black burst and tri-level sync are going away. Let's face it, it's too dependable, we got to get rid of it. So we're going to be timing a facility with packets, and that's never been done before. That's one of the beauties of doing the interoperability we saw at NAB with the IP showcase, is the fact that black burst and tri-level is going away, because the whole idea of 2110 is you can put everything on a single stream, the audio, the video, the metadata, you name it. And then we need to time all that. It's all based on SMPTE 2059. And it's called Precision Time Protocol, which has been around. Precision time, I'm going to tell you when it's time to stop, but I think this is important to understand. The black burst is going away, and 2059 is the way to go. For broadcast, it's new. If you want to see more of the history of timing a system, it's called IEEE 1588. That's been around since the beginning of cell phones. That's been around for years in automotive manufacturing, where you're having robots lining up pieces of steel to do spot welds. The entire financial industry is based on precision time protocol. So if you want to find people that know PTP, look around the finance industry. They really know it, because the finance industry in many ways is like the broadcast industry. It has to work right now, and if it doesn't, a lot of money's on the line real fast. So finance people live kind of the same lifestyle that we do. They're always on, and everything's got to work the first time, every time. So with that said, that was the big news at NAB. All the other manufacturers in their own individual booths, of course, they were showing what they had to. But the fact that you could go to one place in NAB and see it actually working was impressive.
Great. Now, to add to that, I mean, this goes that the IP world, we've already been down this road. The industry's there. It's been there. The business world uses it. The infrastructure's in just about every building you go into, every hotel, and it's something that's there, and we're just starting to embrace it now. With the 2110, what examples are you seeing of the companies taking the leap moving forward with building into the 2110 standard? I know you talked a little bit about it there. You know, what kind of drawbacks and concerns do you have, you know, other than like, all right, we have to go black burst and tri-level are going away, we're going over to PTP, you know, NTP to get all of this stuff. And of course, some people are, you know, I don't want to get into networking. I don't want to do this. I don't understand it. It's completely foreign. You know, it's frustrating. You know, and then finally, there are situations where it's not financially feasible, or you know, for other reasons, to move into an IP base and to keep to the SDI. You know, so what are your thoughts on that?
Well, the whole fact is, born IP, delivered IP. It's an IP world. The last holdout was SDI somewhere in the middle of all this. So that's going away. So the fact is, by going to 2110, raster size no longer matters. You can have 38K by 38K display. You can have one with a circle, like a lightsaber. You can do whatever you want with it. So there's flexibility. So wherever we go to in the future, a forklift upgrade really isn't necessary. So with that said, there's people who are pioneers and people who choose not to be pioneers. I'm involved with some greenfield builds. They say we're going to spend hundreds of millions or tens of millions of dollars on a facility. We want to future-proof it, so IP is the way to go, and we're going to be the pioneers. And you know, that's a brave move, because everybody's learning it one day at a time. Everything's really a plug fest. So if that's the kind of budget you have and you want to be a pioneer, now's the time to be there. Some people are saying, not me. I'm going to wait till this is, you know, business as usual. This kind of settles out. I don't want to be a pioneer. I can't afford to be a pioneer, because in reality, 2110 is not something you just say, we're going to do it, throw out SDI, we'll get the chainsaws and the forklifts, and we're going IP. It's an interface. It doesn't make you any more money. It does not really make the product any better, but you're future-proofing for where you need to go to next. So there's a reason for some to wait. There's also a reason, some people I'm dealing with that say, we're not going to do it. There's no business reason. For example, you have a small OB truck. You want to do 4K or a high dynamic range? Look at 10 gig SDI, because out goes to in and you're doing video. There is no outgoing to in the IP world. Everything is about configuration. So in the heat of battle, you need someone who understands configuration. So small OB trucks probably will stay SDI foreseeable future. The big OB trucks like Game Creek, NEP, you name it, they're always up against 80,000-pound weight limits. So anything they can do to save weight, they can put other stuff in the truck. So getting rid of coax and going to IP and fiber, that opens up a whole lot of capabilities they can add to that truck just by getting rid of some weight. Also in facilities like, for example, some of the Caribbean islands that were hit by hurricanes, they're in a rebuild mode. They're going to go with SDI because they need to get on the air fast. They don't have a lot of talent, a lot of staff. They want to go with something tried and true to get back on the air. They're still in recovery mode. So everybody needs to look at it. Where are you now? Where do you need to be? The staff, because as I said, opportunity for young people, you have to understand that data is not the same as what we're doing in television. Because data, there's the ability to resend. There's the ability to not worry about smoothness, because data can be very bursty. What we're dealing with in 2110, for 1920 resolution horizontally, that's 4 IP packets per line. Every packet needs to be right here, right now, in the right order. There's no resending, there's no reshuffling, you don't want to have buffering because that adds latency. So the whole idea of taking data people and saying, oh, you're the video guy now in this IP world that we live in, that's the biggest hurdle they need to understand is smoothness. My son is an IT professional responsible for a global secure video network for the military. It's an IT network. He does not worry about smoothness at all. He says, you worry about stuff in video I never worry about at all in a global network. Smoothness, if it gets there, it gets there. But the business we have, smoothness is everything. So as you go through this learning curve, anything you can do to smooth out your network, which means everything needs to be PTP aware because the packets need to be smoothly going through every switch and every device in the network or else you can't time a network. So it's all about smoothness. So anybody's moving from IT to video, that's the biggest thing you have to realize. How can I make this network smooth?
And I mean, on that topic of PTP, it's not so much making sure that everything is PTP aware, but your actual PTP design and where your grandmasters are, where your border clocks are, how it distributes through your media network. As somebody that's currently, we're like semi-pioneer, I think, right?
No, you're a pioneer.
We couldn't, we couldn't go 2110 because we started designing 2 years ago and the stuff didn't exist. So we're going to be a 22-6-7 shop. In the meantime, I have to figure out maybe a year or two down the road, once more of this is baked and products are out there, how to make that transition from 22-6 and 7 over to 2110 and all the opportunities that it'll give us. But one thing that we have learned through our current build process is PTP is so intricate in everything that we do. And when you're not only shoving video, but AES-67 streams around, that's going in and out of our audio board. And you know what? No PTP, no audio, period. You look at the AES-67 spec, and I've seen it once. If there's any little jitter in the network or if those PTP packets don't quite make it, then you have no audio, period. So it's a mildly frightening thing to think about that at least with Blackburst, if it went away, you could kind of hold for a little bit. There's some things in PTP land that gone. So
just like to follow up on that, by going to 2110, the whole idea is everything has a separate stream. You need to get all those separate streams back together. The only way that happens with stable PTP. If you remember anything from tonight from Karl, if you're having trouble with PTP, remember the term boundary clock. Boundary clock. That's how you have a grandmaster clock that's talking to boundary clocks. The boundary clocks then talk to the dozens, if not hundreds, of devices. It's like a chain of command in the military, an org chart in a corporation. The boss, the CEO, does not need to talk to the person working on the front lines. So you have a boundary clock that isolates the grandmaster from all the slave devices out there. So remember one thing, boundary clock.
Thanks, Karl. I'm going to keep moving forward with you, Tony.
There'll be a test on this later.
It's called the rest of your career.
And I think the term you were kind of dancing around, which you come up with, is sending deterministic video over a network. And normal TCP IP traffic is not deterministic by nature, but video and audio absolutely is.
And your traditional IT staff don't really, like Karl said, they don't really understand the video. They just understand, well, it got from this point to that point, I don't see what your problem is. They don't see the timing as an issue, and they're starting to. They're starting to learn that, and it's a very important part of the chain. But I'm going to move forward with Tony here. You're moving forward with replacing, you're using IP packets to move things around. But you also have another challenge. You're dealing with repacking. The FCC is requiring almost 1,000 different stations to repack and go from what's labeled as your channel to something else. You have a virtual channel, channel 10, and that's what somebody turns, hey, I'm watching channel 10. But that doesn't really mean anything anymore. You're pre-packed right now to 34, and you're going to get a post pack of 28. What kind of challenges does that present to you? And is there anything at NAB that you saw that would help WCAU and other people move forward with that?
Yeah, so we had two challenges. First, ourselves and several other markets, we sold off the Telemundo spectrum. So now we're doing full channel sharing with Telemundo 62 and NBC 10 off of our Roxborough transmitter. We had the benefit of doing cross-transmission. We had set that up a little over a year ago, so we were broadcasting a 62.3 and 4 off of WCAU, and then we actually put NBC 10 masked as 10.3 off of the Telemundo transmitter out of Waterford Works. So we kind of expanded, got better coverage out at the shore from the Telemundo transmitter. And they got the added benefit of a lot more of the DMA thanks to our Roxborough transmitter. So we recently had to vacate the Telemundo spectrum, and I really thank God that we did that cross-transmission, because what we ended up doing is we just added a couple extra PSIP virtual channels on our transmitter over here, so we're actually doing 62.1, 2, 3, and 4 off of our stick here, and I think that helped us an awful lot. That was a little bit of a challenge. So we're all on one stick, and August 2019 we're a phase 4 repack station. So we're actually in process right now of destroying part of our transmitter facility and rebuilding out with the new transmitter on our new channel, and got a long road ahead of us to make it to August 2019. The interesting part about NAB was there's not a whole lot of transmitter manufacturers out there anymore. What, 2, 3 left? So it was tough. It was actually tough at the show, and I was kind of surprised how little was focused kind of around repack. Right? You had Hitachi and a couple others out there that were showing off their transmitters that I don't remember from the year before. So I think they're kind of anticipating the big repack spend that's starting to come in. But yeah, by and large, it was hard to find the repack.
I'm going to ask you a second question. It's a little bit further down the road for you, but ATSC 3.0. Looking at that, how can you attract mobile users into this market with OTA services, and just kind of what do you see? People in coffee shops and other areas that, hey, I've got it on my phone, and yeah, the carriers aren't going to want to get into that because you're not getting service from them. You're going to get it from over the air. But what are some of the things that you saw or that interest you on this?
Yeah, the ATSC 3.0 is. It's fascinating to me, right? There looks like there's a lot of opportunities with everything that they want to bundle in there. The fact that they're going to be putting a little data and presentation layer on top to interact with. They have specs out there for HTML5 on top, a little return channel to come back, and you think about, well, not only can I maybe do more targeted ads based on information I'm receiving back from the viewer, I also have potential to do things like video on demand. I can deliver more customized content to them, maybe even really hyper local ad insertion to them. So there's a lot of positives around it. The interesting part, and Mark and I had chatted about this a day or two ago, is it's not even a blip on my radar yet to think about. Post repack. And then getting through, waiting for the standard to get ratified, because there's still a lot of details to be worked out. So it's going to be really interesting to see what comes of it. the potential and the theoretical that's out there surrounding 3.0 is really fascinating, and I think it could do a lot for the industry. But we definitely got to get some early adopters. We've got to get probably a lot of big station groups, you know, the NBCs, the Foxes, the ABCs of the world, to really, I think, develop for the platform and what it exists, because it's going to be a highly complex rollout, I think, and then really trying to monetize it and make it worth a while. It's going to be a fascinating journey. So maybe in 2020, 21, start to really.
But it's a ways off, yeah. It's coming, and you know, technology is not going away. It's just going to keep hitting at us, and the more that people want, and the younger generations that they're coming in, I expect it now. You know, why don't I have it now? And you know, just like they want network wherever they're at. Mm-hmm. They want to watch what they want, see what they want, look up what they want whenever whenever the thought hits them. So I'm going to move on to Pete here and ask him something similar but related. And 8K resolution, okay, is gaining new ground for acquisition. You know, it's possible to capture the footage, but editing, storing it takes a lot of storage space and a lot of processing power on there. Streaming it, you know, 8K, that's a whole different thing. And sending it down some type of pipeline, it really has to be an IP signal on there. But one of the streaming things was JPEG XS. You know, it's one of the standards that people are moving forward with. And Pete, at NAB Fraunhofer, they demonstrated it was as part of Adobe. What demonstration did you see this? You know, this demonstration or others where they use this codec? And you know, what are your thoughts on 8K and the JPEG XS codec?
Well, before I answer that, let me ask the audience a question. How many of you now have a 4K TV? Show of hands. It's a little less than half the room. All right, so the rest of you guys are smart. You might as well wait for 8K at this point. 8K TV is really an example of we're doing it because we can. It started with the availability of 8K displays. Those of you who've gone to NAB have seen NHK has been broadcasting 8K in Japan since late 2010, early 2011. They've done every Olympic since then in 8K. And we're starting to see an 8K infrastructure get built up as a result of that. So this year, Sharp showed an 8K broadcast camera ready to rock and roll. It's about $80,000. You might be surprised to see Sharp in the broadcast camera market, but they're going to be very much a player. Their cameras are going to be used at the next Olympics, which will be a Summer Olympics in Japan. So yeah, immediately, those of us who do math very quickly in our heads are calculating some data rates off the cuff and thinking, holy cow, are they going to get that through the system? So yes, Fraunhofer did show JPEG XS. There's another name for that, by the way. It's called TiCo, Tiny Codec. It's a whole bunch of companies that have signed on to it. It's basically JPEG XS, which is what they like to call mezzanine compression. And like any JPEG format, it doesn't tolerate a lot of compression well before it starts to break up. So NHK actually showed 8K using JPEG XS compression to get down from somewhere in the ballpark of 40 gigabits a second to maybe as much as 48. 6-to-1 compression to get down to 8 gigabits a second to go through a 10 gig switch. They had a before, they had an after. The material they were encoding was pretty difficult. It was people swimming in a pool. So not only do you have the temporal and you have the spatial vectors, you also have water splashing all over the place and specular highlights. But I was very impressed at how good it looked. I was very impressed that they were compressing a JPEG signal down 6-to-1 and it was still tolerable. So what's happening is that as this move to higher resolutions continues, and by the way, it's not going to stop with 8K. I mean, you're going to see it go even higher than that. And again, it's because we can't. There's some crazy people out there that think, hey, why stop at 8? Let's go to 10, let's go to 12. But the problem is, again, getting it through a pipe. And right now, 10 gig switches are affordable. That seems to be the infrastructure everybody wants to go to. You can buy 40 gig switches. They're kind of expensive, pretty much operating at optical fiber territory at that speed. Although some people like John at SMPTEE has told me, yeah, we can do that with copper. I mean, it's not inconceivable. And we're going to start to see 100 gigabit second switches. But to give you some idea of just how fast and how much data an 8K signal needs, if you're going to do 8K at 60 hertz, and if I don't have the numbers exactly right, don't shoot me, but RGB 444, 60 hertz, 10-bit color is roughly 96 gigabits a second of data. And if you're going to do high frame rate, which by the way is going to be a real thing, and it's going to come along with 8K, then double that. So 120 hertz, 192 gigabits a second. That's streaming through your network. You know, some of you right now are saying, yeah, that's like being able to do time warp travel. It'll be about the same time both of those things happen. But there's a lot of momentum behind this 8K thing. And it's not just Sharp. It's other companies that are hopping in and saying, well, maybe there's something here. On the display side, it's the Chinese. Chinese are building Gen 11 fabs, and they're going to come out with 8K displays. LG is already showing a flexible 77-inch 8K OLED display. So this isn't just, you know, crazy stuff. There's actually an infrastructure being built here. And one of the things that NHK showed, in addition to the JPEG XS, was super slow-mo with 8K. So they were shooting video at 240 hertz and slowing it down to 60 hertz. And they were showing batters hitting a ball, running, you know, across first base or sliding home to see if he was safe with the tag. Other fast motion things. In fact, you could even go in the booth and you could shoot free throws and they could slow you down. Looks beautiful, 60 hertz. So there's a slow-mo application for it. There's the application of shooting 8K and down-resing to 4K or even 2K. A couple of years ago, one company showed a soccer match that was shot with 2 8K cameras. They covered the entire field, and they had 16 different 2K windows they could extract at any time for a close-up to show any part of the field. So all that's possible, but again, the data rates are the elephant in the room. How do you manage it? How do you stream it? And not only at that end, but at the display end too. That's a very, very fast connection.
Okay, thanks. The other side, that HDR, that's another hot topic, and there are several different flavors of HDR. Familiar in the States here, the HDR10 and Dolby Vision. There's also hybrid log gamma and Technicolor HDR, which are more popular outside the U.S. Basically, we see HDR10 is predominantly the main player right now, followed, you know, closely by Dolby Vision. But it's kind of like we're going back to the VHS beta wars and just rehashing that. You know, there's a higher acceptance rate versus, you know, Dolby Vision has a wider gamut. So, what did you see at NAB that being more likely adopted in the U.S. as a standard, and what are your thoughts on some of the different HDR technologies?
Well, I'm going to quote some of my friends here and say I love standards. There's so many of them to choose from. There's basically 5 ways to implement HDR. And really, the right way to look at it is sort of like the roots of a tree and then going up like this. So at the root is HDR10, which is derived from SMPTE ST2084. Every TV that supports HDR supports HDR10. It's a very basic implementation of it. It's basically static metadata. So whatever comes in from the source, that's what your TV is going to show. Every other system you see, and I'm going to put Technicolor to the side for a minute, incorporates dynamic metadata. So there are more things that TV can do with it. Dolby Vision is a proprietary format. That's dynamic metadata that's being mastered at 12 bits and dithering down to 10 bits. Because one of the problems we have with HDR is that annoying little interface that's spelled HDMI, and it's called HDMI because all the other 4-letter words were taken, but that's an old golf joke, by the way. But HDMI right now, the most widely used implementation in the consumer world is version 2. Version 2 is a capped data rate of 18 gigabits a second. So you can feed whatever you want into the TV, but if your combined data rate for whatever you're feeding in with HDR exceeds 18 gigabits a second, and that includes the overhead, you're not going to see it. So HDR10 delivered off optical disc or streaming is typically Ultra HD with HDR10, 420, 8-bit, 60 hertz maximum, because that can get under the bar, that can go through the pipe. Dolby Vision is a proprietary format, requires a license. It's 12-bit content dithered to 10-bit. It's based on what we call scene referenced HDR, so there's no cap to how bright it can be. And in theory, Dolby says you could master it at 10,000 nits. Get a nice tan too doing that from the display if it doesn't burst into flames. But they're saying that Dolby displays that can do 2,000 nits and 4,000 nits specular, not diffuse white, but specular white, like the sun glinting off a window or a glass or off a splash of water. So some companies have adopted Dolby Vision. I believe Sony supports it. I know LG does. I'm not sure. I think Vizio may also support it. Then we have what's called HDR10 Plus, which to me is a very unfortunate choice of a name, but this is Samsung's version of HDR, dynamic metadata. And the best description of it is it's not Dolby. So Samsung came up with their own version of doing dynamic metadata. It's now incorporated in SMPTE standard ST2094. It's just a different way to get to the same place. So they claim they can do everything Dolby can, just that it doesn't require a license. It's something right now that anybody can use. So as opposed to calling it Samsung dynamic metadata, they want to come up with something catchy. And at the HPA Tech Retreat a couple years ago, they were talking about HDR10 Plus. And we kept saying, don't confuse it with HDR10. It's confusing enough already that consumers will just, they'll go nuts. Call it something else. So finally I said to these guys, and remember, these are people from Korea that work in a lab in Palo Alto. I said, call it HDR11. How many of you have seen Spinal Tap? You know what I'm talking about. Well, the security guard got it. They didn't get it. So it's HDR10 Plus. So right now, that's being supported by Panasonic. It's being supported by Samsung. And a couple of other companies are behind it. So that's a competitor to Dolby Vision. So again, at the bottom, at the root is HDR10. The Dolby Vision builds on that. It's proprietary, requires a license. HDR10 Plus goes in the other direction, but supposedly does everything Dolby does not require a license. Then you have two other standards. The fourth one actually, would be hybrid log gamma, which is developed by the BBC with a little help from NHK. That's not really any metadata at all. That's a gamma curve that is basically sent to your TV, and your TV reproduces as much of the gamma curve that it can. So that if it clips white at, let's say, 1,000 nits, everything above that is compressed. If it clips black at, let's say, 0.1 nit, everything below that is compressed. If your TV can do 2,000 nits, then the gamma curve continues. So the nice thing about that is it'll probably be adopted for broadcast because it can be used by any HDR TV because it's not metadata. The TV doesn't really know, doesn't have to know what to do with it. There's no special signaling. It just takes the gamma curve and reproduces it as faithfully as it can within the limits of its dynamic range from full black to peak white, whatever that happens to be. So HLG probably will be the one that will be adopted for broadcast because it's very simple to implement. It does require a separate flag. With HDMI interfaces, you have extensions. You have A, you have B, you have F. So F is basically saying that this is an HLZ signal. Do with it what you will. The last standard is the Technicolor standard, which was very similar to Philips. So Philips and Technicolor kind of blended their efforts a couple of years ago. That's really more for signal transport. The trick there is they're able to take both SDR and HDR and have it travel in one transport stream. So they can extract SDR content for devices that can only show SDR, and for devices that can show high dynamic range, they can extract HDR content. So that's not necessarily a standard that is going into the TV. It's really more of a transport standard. At NAB this year, they were showing a form of splicing. So they were going back and forth between PQ, which is basically Dolby Vision, the version they were using, and HLG. Because as somebody pointed out, well, what if you have a program that's in Dolby Vision and then you go to a commercial, it's in HLG? How long is it going to take your television to recognize that? And then come up with the correct dynamic range. So they're on top of this problem, and they were showing pretty quick transitions back and forth between the two formats. They haven't done anything with HDR10 Plus and any other standards that are out there. So for the time being, it's this jockeying back and forth between HLG, again, which is no metadata, and then Dolby Vision, which is Dolby's dynamic metadata, and then HDR10, which is basic metadata. I hope that confused everybody adequately.
Yeah, I'm sure. Yeah, thank you all for your answers and in-depth answers. I really appreciate that. Right now I'm going to open up the floor to any questions that you guys have, and it can be on any of these topics that we discussed. So, go ahead.
Yeah, in conjunction with the repacking and the 3.0, are they going to find enough channels, RF channels, okay, run essentially two separate sets of the same thing, except one of them is going to have so much crap on it that it's going to be useless to watch. I look occasionally at some of these channels that run 6, 8 subcarriers, and it's like, forget it, I'll read a magazine.
Well, so with 3.0, you're going to have to change your set-top box anyway, right?
No, I'm talking about over the air. The whole set-top box.
No, well, but with 3.0, the way we're going to deliver it, you're going to have to get something new to receive it.
Yeah.
Period. So I don't know. I'm hoping that maybe either H.265 or there's going to be some better compression out there, so that we are cramming all of this programming down the little slice of pipe that we do have, we can still maintain quality. I think that might be part of one of the details that they're still trying to work out. But I got the same concern. How do we, we only have so large of a pipe. How do we balance quality versus the content delivery that we want to do? I already know the data itself that we're going to shove down there is going to be small anyway. But how much different video sources can we shove down? And with the adoption, maybe 4K or 8K or whatever, how can we cram that down the pipe and then still maintain some other either multicast services or video on demand or other ways to monetize the bandwidth that we have? It's a great question. I don't know how it's gonna shake out.
Can I make two observations on that? To me, the biggest hang-up with this ATSC3 thing is, you just mentioned it, you gotta replace your set-top box or your sidecar box. How many consumers are going to be willing to do that or even care about it? And will there be an FCC mandate that televisions have to support ATSC3? We haven't heard any indications at all that's going to be the case. The most practical way that I saw to deliver this to people is several companies were at NAB, they were there last year too. And what they are proposing is a Wi-Fi router that would have an ATSC3.0 receiver in it. So your antenna connects to that. And then once the video is decoded, it goes out as IP over a Wi-Fi network. And you use an app basically to watch it, to stream it. So if you have an 802.11ac channel bonding modem, which is what you're going to need at the minimum to do it, you can be anywhere in the house and watch on any device. Smart TVs have Wi-Fi connections in them anyhow. But the feeling is that the average person is not necessarily going to rush out and buy another box to connect to a television so they can watch over-the-air TV. There has to be a compelling reason for them to do that, and it's got to be cheap. Like the old converter boxes. And this is going to be a much more complex thing than the old converter boxes. Second observation is, get ready to dust off no man's land, channels 2 through 6. Because what the FCC should have done when we went to digital TV was abandon them altogether because of all the problems with e-skip, sporadic impulse noise from vacuum cleaners. I mean, if you take a spectrum analyzer and look at channel 2 through 6 in Philly, it's a mess. It's terrible. So there's no way to predict how good the reception is going to be, and yet nobody else wants those channels. So the FCC, as of a few years ago, before all this started with 3, there was about 44 stations operating nationwide between channels 2 and 6. So there's plenty of spectrum available there. The question is who really wants to use it. And of course there's a lot of repeaters and other stations going there. So yes, this is trying to put 10 gallons in a 7-gallon hat. A lot of that's going to wind up moving back to low-band VHF. And I just don't think that's a great idea, but it's going to happen no matter what. Sorry to sound like the voice of doom and gloom there.
What do you think about low power? Opening up a whole new market for low power transmitters in small centralized areas, like let's say in stadiums, so you can get, you're a total different approach to it. You're not really caring about the media, the video, you're caring about content you can get to as many people as cheaply as possible, rather than putting a bunch of of wireless hotspots around.
But somebody's got to put a receiver in these things. There's got to be a receiver chip in here to do that. And are the phone manufacturers willing to do that?
Or even turn on the FM chip. It's already built in.
Right. So the question is, are they willing to add that? That's a new layer of silicon that has to go into a phone. And they don't necessarily want to do that unless they know that somebody wants to watch. And keep in mind that we're starting to see noise from people like Deutsche Telekom and Verizon and AT&T about 5G. Some of these guys have even been so bold to say is, once you're on 5G, you can fret about Wi-Fi. You'll never need Wi-Fi again. This is going to be so fast, it's going to blow you away. Well, they might say, just get a 5G phone. You can stream all the video you want. Just get an app for your local TV station and watch it that way. Don't worry about hooking up an antenna to your TV and all the other stuff. So, I mean, there's more than one way to get that content into your phone. And 5G is, you're going to see a huge marketing push for it. There's already, the infrastructure starting to be built out now. It's going to take a while. But some of the speeds that Deutsche Telekom is talking about delivered to your phone, I mean, I can't say I would argue with them. What would I really need an ATSC receiver here for? I can just stream it off their cell towers, whatever the content is.
Yeah, if I get 1 gig to my cell phone, what else do I need?
Yeah, exactly. And that's what they're talking about doing. So why do I need to worry about whether I can pick up KJWP on channel 2? I can probably find a KJWP app and I can just watch it on 5G and I'm done. So I don't want to sound like, Debbie Downer here, but this rollout of ATSC 3.0, there's some serious potholes here that we need to be thinking about ahead of time if it's going to be accepted by the public and it's going to be successful. And with ATSC 1, yeah, it was a pain in the neck to convert from analog to digital, and some channels went away and everything, but there was no other way to do it. Back then in 2009, it wasn't practical to be able to stream stuff to your phone. Well, now it is. It's very practical to do it. And it's very practical to stream it within your house using your Wi-Fi router. And now we have faster versions of Wi-Fi coming out. We have 802.11x. We have 802.11ad, which runs at 60 gigahertz, which isn't going to go through walls, but that's perfect for in-room distribution. The 2 gigahertz wide channels, you can stream at insane data rates up there. So there's lots of different ways for NBC as a company to get, you know, the blacklist or the voice to me, not necessarily through a standard RF transmission path. There are going to be other options. So the question is, how committed is everybody to doing this transition? And is everybody thinking down the road like, well, what if, you know, Verizon and AT&T get 5G going? How's that going to impact us? You know, what if, you know, Google decides to come in and do free Wi-Fi or some crazy thing like that? You know, what are our options? And what channels will be available to us, and what limitations, RF and propagation limitations, will we have to deal with on those channels because we're stuck there? So.
Oh, go ahead.
Do you ever see it on, where over-the-air television is going away and everything's just be IP delivery?
Well, I mean, the FCC is doing a pretty good job of throttling television now. You know, some of you that, and I'm not going to imply that some of you are old here, but you're old enough to remember that when BBC went from 425 line black and white to color, what else did they do? Shut down all their VHF stations and moved everything to UHF. And there were a lot of good reasons for doing that, especially being able to provide TV service in rural areas. Because of the directional nature of the signals and everything, you can put more stations on the same channel with, you know, certain spacing and not interfere with each other. But we seem to be running backwards from that. We're taking the UHF spectrum away and pushing everybody back to the VHF spectrum. And I'm testing right now a smart antenna from Channel Master that's got active electronics in it. So when you hook it up, it scans the entire band, and it has patterns built in. It changes the elements within the patterns. And I'm cycling through it, and it does seem to help. I'm having some trouble. I live up in Bucks County. I'm having some trouble with WCAU right now with dropout. And it seems to improve it. But it's this big. It's going to be totally useless on channel 2 through 6. There's no gain there.
One of the interesting things that I'm seeing, and my business is almost all screen, we screen hundreds of hours of broadcast, is I'm watching what YouTube is doing. Because basically for $30 a month, you can stream 4K content through the internet, and every single major network is now on YouTube, or YouTube TV channel. So basically, why do I need over the air when I can just stream it electronically?
Well, there's another side to the story. Okay, I'm approaching it just from being pragmatic technologically. The other side of the story is you have these people called cord cutters. Okay, they've decided that they're just paying way too much money for cable. They're not watching enough channels. Their first move is to try to stream everything and go to broadband. When they find that doesn't always work, and they want to get the local stations, then they discover that little threaded, you know, connector on the back of their TV. Like, hey, cool, I can put an antenna on this and get it over the air. So, by all indications, the cord cutting movement, which is not enormous, but it is growing slowly. A lot of those people are trying over the air. I just stumbled across a website today, the best HD TV antenna. We kind of abuse them of that. An antenna is an antenna, but this guy is getting everybody excited about, hey, you've got this thing on your television, hook it up and you can watch for free. So, and he's advertising like 10 different kinds of antennas there. The question is, will there be enough pickup from those people that whoever the powers that be can say, well, we can't really do away with over-the-air television completely because there's 20 million, 25, 30 million people watching it, which isn't really a lot considering we've got over 300 million people in this country, but maybe that number climbs to 40 or 50 million. Well, that's a substantial number. That's a cable system right there. So the answer to your question is, I have no idea. This is really hard to predict, you know, but I'm trying to put myself in the shoes of the consumer who's watching on some device. I don't know what that device is, but most of the consumer devices do have Wi-Fi in them, and they will support 4G, and down the road they'll support 5G, except for televisions. And is that the pipe? It could be. You know, maybe that's the way to go. Does that coexist with over the air? It could. You know, one of the reasons it would make over-the-air attractive with ATSC3 is all the different bells and whistles they can add to it to make it more attractive to you as a viewer. And if you find value in that, then you might say, yeah, what the heck, you know what? Maybe it's a USB stick plugs into my television and that becomes my receiver. That works, okay? Because remember, it's a different codec that we're using.
You said that because I'm seeing more and more of these HDMI antennas where they plug into the HDMI devices
Yeah.
and they pick up over the air. And we actually played with one the other day in your house, shocked at the quality of that.
Yeah. Well, hey, it's just demodulating a signal, that's all. Yeah, but whatever's in the signal. If it's HD, it's HD. It's going to be as good as whatever's coming over the air. It's not going to alter it. Yeah, Hotpog's been selling those for a long time. I have several that I travel with. They're this big. But remember that I could be in a city where there's a bunch of Vs, low-band Vs, and if I hook a little panel antenna to it, I'll never pick them up. It has no gain at that frequency. It's not going to work. So that, to me, that's the big stumbling block, is how heavily we're going to be relying on high-band V and low-band V in some markets. And people are going to say, yeah, I'm buying into this. I want ATSC3. I'll get one of those receivers. They hook up that little smart antenna that I tested. They don't pick up any signal at all. I've scanned like 10 times with that. It won't pick up channel 12 and it won't pick up channel 6.
Right.
Yeah.
My question is for John Fox. Just believe you brought this up. He's going to be the chair for next year. I would mention that.
All right.
Like me. So, John, he was asking, how do you stream? I mean, you don't have a stick or a transmitter.
Right.
What's his question here about YouTube? How do you deliver your content?
So we have our videographers go out in the field. We have laptop with Wirecast software. Put the graphics on. We'll stream that to Wowza or Bright Cove as our provider, and we have a mobile app, website. You can subscribe to our content, and yeah, we're looking also at the LiveView Solo. LiveView had announced cloud graphics for their product. So right now, our videographers they'll have a camera, a switcher, a recording device, and then a laptop, and they're pretty well spread out when they're going out to shoot an event. And this Solo would take the place of several devices, so that we can make their job a little easier, and it'll still stream to our website or mobile app, but then the graphics can be added in the cloud.
I'm going to take a hard left turn and go more on the direct side. This is probably for Tony and John. Was walking around the floor. This is the second year I didn't work for a manufacturer, so I was really walking the floor. And what I noticed was, I'm seeing here, lights, lights, and more lights. So Tony, like when you were planning out the new facility, we saw everything. This is more on a production side. We saw everything from lights that cost $300 up to whatever you wanted to spend. With this plethora of these new LED lights, it seems like they're coming every which way. How do you choose, and why did you choose?
It's tough because you're right. Everybody's making lights. For us, when we demoed a few different companies, ultimately we'll have a lot of light panels, and Cineo I think is going to be the bulk of what we're going to end up with. And we went with them. You look at how true are the whites, what kind of what other colors can we blend in, how do they blend it in, how robust does the power supply look, what's the build quality. It's just all the things that you would look for in any old light that you buy, right? Just how attractive is it? The controls are pretty much, that hasn't changed any. So even though there's a ton of light products, I think a lot of folks were just flooding the market with all sorts of different LEDs, and I'm sure there's probably some pretty good profit margins on there, which is why we see all of these companies out there with the lights. But we stuck with what we know. They had solid products. I think the one thing that we were really hoping to get more of, and we'll still get more of through Cineo, and it was something that NBC Universal developed out west, was the light blade. And that was an interesting product, just because it will fit applications for lighting out in our newsroom. in some of our other tech areas. Some of our outside of the studio, it's a really slick product, and it's just a light bar. That's all it is, but it's really well designed and implemented, and I think it'll allow us to light in situations that otherwise, as I walk around, I'd be clanging my head off of the light that we would have to hang. So the Cineo, and it's made by Cineo, it's developed by NBC Universal, but the light blade was pretty slick.
There's, just to add to that, there's a lot of other things now when you're looking with LEDs, There's heat from it that you don't really think about, but the light engine, there's heat from it. So how is that dissipated? How is that taken care of? And if it's not taken care of properly, like with some of the cheaper units, the lights will die faster. They'll go to their half-life faster. They'll change color faster. And then this light will look different from that light. So if you spend a little more money, and you're looking, like I said, you're doing the research, you're looking at it, Light Panels has some great stuff out there. Chroma Key started the market. They've got some products even with, I think there's a couple of NBC stations have their phosphor LED on it that it's like that light bar. It's very small, so you can put it up there, a lot of light, it's very flat. And then there's spotlights that you need. It's a single source LED, so that it's really changing. Fluorescents you see here are going away, tungsten's going away, and you can go, just about anywhere and find LEDs. I just bought a new house, and I went through and took out all the CFLs and the regular incandescents, and it's now all LEDs. So the market's all moving to LED, and it's just not going to change. So, yeah.
I deal with in my company, I deal with a lot of brands. So what I look at, so I used to work for Mullen, so I have experience. Which is kind of disappointing. I look at companies that don't just make a good product, it's very important. It's service. There's a lot of Chinese and Taiwanese lights out there that are really damn good. But when you start talking to them, besides the fact you can do the temperature, there's no backup. So that's
support, yes.
I feel that's very, very important to make this decision. The brands are neutral, so I have no problem they've got it. But when you come across some of these new lights, they may be very good, well made. The service isn't there, but the backup isn't there. It's not worth it.
And you see that with a lot of companies now that are, what happened to the service? Not just with LEDs,
They don't think about it until something goes wrong and that's a problem.
But go ahead.
I guess more to Karl, maybe a little to Tony. With all the new technologies coming out, were there any test instruments that would make a big difference if you were redesigning a studio? Or how do you keep track of all the stuff that used to be done with analog gear, making sure your video quality's there, your synchronization, your levels? Were there any breakthrough things that somebody redesigning a studio would put in to have to make a go at it?
So I'll let him talk about the Prism, which we have several of in the new facility downtown. It really helps analyze the data streams, to look at the video quality, look at a lot of the traditional things. The one interesting part about the Prism is how it's implemented, because now you're in an IP world, and you're not taking a patch panel and patching into test gear anymore, right? I have to reroute a data stream, and then once you take away, all right, not the audio quality, but if I'm just mirroring one data stream from this switch port to this switch port, am I actually getting all the information that I'm having the problem with on my other endpoint? So we looked at a different solution with Cisco Data Broker to really kind of manage everything that's going across our media network and say, all right, every single packet that's going to that endpoint, I need duplicated way down here to the Tektronix Prism. So you not only have to have the right test gear, which I'll let Karl talk about, but you also have to figure out how to get that data stream replicated to the test gear as faithfully as possible. And that's another interesting little challenge that we didn't even think of until we started to dive into it and realized, well, wait a minute, I can't just mirror a port, or I can't just do this. I have to figure out a way to now manage all of these media streams and get it to the Prism.
Thank you. Great question. It's a great time to be at Tektronix, because the more confusion there is, the more people need test equipment. Let's be blunt about that. Because what we're dealing with now, we had analog. Back in the days, you take your greenie tweaker and you turn the pot, you can see the video or the audio change. Well, then we went to SDI, we had the cliff effect. Now we still have audio, video, and all that stuff, but now we added an IP layer and precision time protocol. So all these different layers, you're dealing with more layers of abstraction. It's like your car. My great-grandfather has Stanley's steamer, steam-powered car. Adjust this valve, this gauge here, this lever goes there, and off you go. With any luck, you don't blow up on the way to where you're going. Then we got involved with cars, at least my age. There's distributors, there's carburetors. It was an analog device pretty much. Now your car, without instruments to look at all the different codes, there's no way to have a clue what's going on in your car. And with video, we're getting to that point. We just keep adding layers that are moving further away from the audio and the video. And the big challenge, and I'm sure Tony sees this, as I mentioned earlier, it's all about smoothness. How smooth is my 2022-6, my -7, my 2110, my precision time protocol? If you don't have smoothness, you have lost packets, you don't have video. When you fall off that cliff, where in your network is the problem? I see test equipment now being in all the interops and plug fests and all the things going on in the industry. It's the judge, jury, and the executioner. Because you keep hearing, I guess you've heard of finger pointing. You know, you've never done it, but you've probably read about it on the internet. It's rampant because, you know, it must be your beta code. No, it can't be my beta code. It's your beta code that's the problem. And it goes on and on and on. The only way you get to the bottom of it is hook up an instrument and say, here it's smooth, here it's chaos, and your black box is in the middle of it. And then you go from there. Because the only way you fix anything in today's world, the digital world, is to have an intelligent conversation with the manufacturer that you're questioning. You do a screen capture, you do a stream capture, a PCAP, and you send it to the manufacturer with a screen of actually the plotted graphs, because in the IP world, a flat line is good news. Unlike the cardiac intensive care ward, here a flat line is what you want. Smooth is what you're trying to see. So if you don't see smooth, you see a signature over 1 minute, over an hour, over a day, over a week to see trending. You send that to the manufacturer, then you're having an intelligent conversation to say, here's what I'm seeing. Over here it works, it's smooth. Over here it's chaos. What do we do about it? So test equipment is big. As Tony mentioned, Prism is in the middle of it, won a whole bunch of awards. It's exciting times at Tektronix.
You also get to think about, again, that IP layers. As you say, you know, as we keep adding more layers, while we're using the Cisco data broker to kind of manage where our streams are going so we can analyze the video within them, you have to be concerned about the streams itself. And as you know, Karl says, if you lose packets, you got problems. Well, now, where am I losing packets? So the other thing that we're implementing was Cisco's DCNM, Data Center Network Manager. And they have a lot of interesting plugins. They developed a Media Center plugin that really helps visualize the flows throughout your media fabric to kind of keep tabs on not only packet counts, losses, your standard runs, giants, all that other stuff that may happen as another tool to help the engineers kind of figure out, all right, where is this going? Because unlike the SDI world where it goes through that single cable, I know point A to point B, and I'm done. Now it goes off into this media fabric, and from the source to the destination, who knows where it goes, right? And in our world with the 22-7, we've got 2 media networks. So now, if I'm on the receiving end, how do I know, is it my X side that's having trouble? Am I still getting Y side? I mean, that's why we're doing what we're doing with our redundancy, to make sure we have 2 paths at all times and a perfect merge on the receive end. But we still have to figure out, all right, which side is it? What network path is it? Where are those packets going? And then how can we look at those packets to make sure that they're all in order?
Quick follow-up. Once you do a reboot, you have the firmware that the manufacturer recommends. What do? You need to know how to visualize the problem, and configuration is the biggest thing. If things are configured correctly from end to end, you have a good chance of it working. If it's not, it can't work. The good old days of a BNC connector out going to in are over forever. There is no such thing as out and in. There's no such thing as a patch panel. It's packets going who knows where and hopefully coming back together to mean something. It's a layer of abstraction that we've never seen before in this industry.
It's any to any. That's what I got a couple of my engineers in the back, and that's what I keep telling them. It's any to any. There's no point to point anymore. It's a pretty interesting little world.
Now you know why so many guys are retiring.
Yeah.
And it's quality of service has to be there too for it. And I mean, a packet's a packet. The switches don't care unless you try and you specify certain packets are more important than other packets, and you add that to it. That's a whole other layer.
Well, quality of service is the paramount thing. That's an IT term.
Yep.
So it's reliability and quality of service.
But you have to set levels for it.
Yep.
And Cisco lets you do it inside their switches. You add another switch from somebody else into the network, you can't do the same thing. You can't manage it. So I mean, there's other layers that go into this and other levels. Like, all right, what happened to my network? Oh, somebody put in XYZ switch in here and replaced the Cisco. Just doing it off the shelf. I don't know why they did it, but that's when my problem happened.
Yeah. The best way to do the quality of service is just kind of like what we did. Just build a media network. Nothing else goes on it. Nothing else can go on it. It's just pure source destination media. That's all it is.
And block other networks from even realizing it's there. It can travel along the same fiber path, but nobody else knows it's there. It's not sending data packets back and forth to other switches that might be on the same physical network, but not the same
it's
virtual
easy
network.
quality of service when there's only 2 services on it.
So, go ahead.
So, from what I'm hearing, I'm just trying to understand what's being used as the backup and then the redundancy to make sure that everything's getting out to the consumer. As far as the signal or the TV show or the IP, if you're talking about things getting lost and not sure where it's going, where's the backup and the contingency to make sure that it'll reach my phone or?
Well, I mean, for us, within the station itself, there's 2 media networks. So, and every endpoint, again, we're going 22-7, so everything goes out two different networks, 2 different directions, and then ultimately merges on a source side. So we've got plenty of redundancy within the 2 media LANs, that if one media or one switch, whatever, has a problem, the other one is right there to pick up the slack. The destination is essentially looking at all the packets coming in from both network interfaces, and if one's missing over here, fine, it picks it up on the other side. And it does so really well. I gotta say, 22-7 is it's pretty robust. So from that aspect, we've got plenty of redundancy. And then as it goes out to the transmitter, well, there's our regular, XY air paths. We're still maintaining SDI and then all ASI throughout our air chain. That's not IP, but just our entire production facility is based on IP.
And remember, everything that's coming into your TV at home already has latency built into it of about 1.5 seconds using MPEG-2. So if there's dropped packets within MPEG, there's a provision to recover those packets, to resend those packets and rebuild it. That's why you have the latency. If it was real time, it would be tricky. But there could be a dropped packet for whatever reason. Something gets in the transmission path, and a plane flies overhead, whatever. And your TV has a pretty good chance of recovering that packet. You might see a brief tiling on the screen, but the show continues to stream. So it'll be like that with ATSC 3.0, which is based on H.265, which is roughly 50% more efficient than 264, but it's the same thing. There'll be a fair amount of forward error correction built into that, and there'll be latency from the actual time of the event to the time you actually see the event. There'll be some latency built in to recover dropped packets, to keep the bit error rate low.
But that's the hardest part of the chain. From the endpoint here at CAU or whoever else is sending it to you, who knows what it's going through? How many different areas it go into? If it's an IP packet, it goes all over the place before it comes to you and your phone, and you don't know that. So that's what the forward error correction is in there, latency's in there, and yeah, there will be problems. And you can see it with the satellite TV. A cloud goes overhead, a lot of rain, a lot of snow. You're losing packets there, and you're losing the signal. What are you going to do about it? There's nothing you can do about it until something gets out of that path.
Well, Netflix had a problem with that early on. I'm sure we all enjoyed watching the program Buffering. Everybody saw that, right? I watched at least 10 episodes of it one year. So what Netflix wound up doing is building server farms all over the U.S. So there's several servers in the Philadelphia area. Rather than going from one central point and then ping-ponging through all these different switches and servers to get to your house, what they're doing is they have servers built in major metropolitan areas and even outside major metropolitan areas to improve the reliability, to reduce the drop packets. So when you decide you want to watch a Netflix program, it's not necessarily coming from California. It's probably coming from a server farm in New Jersey or Pennsylvania somewhere. And whatever connection is the best connection at that instant, that's the connection that it makes to your house. And they also use various forms of adaptive streaming. I don't want to go into all the details. But what may happen is if the network gets really clogged up with traffic, to preserve the resolution, they're going to actually do dynamic stream shaping of some kind. They're going to drop you to a lower resolution. It might actually be 1080p. You probably won't notice it because it didn't drop out. But maybe it got a little bit softer on your TV, but at that resolution it continued through the network without drop packets. And then once the encoder is pinging the switches in the network and realizing that, okay, the bit rate's gone back up, then it bumps you back up to higher resolution. So there's all kinds of tricks you can use to ensure that you don't see buffering again, which frankly I got tired of. I'm glad they canceled that show. So this is what they do. So there's all kinds of tricks that can be, the encoders are phenomenal today between, leaving the source and getting to you to ensure that come hell or high water, like they say with the U.S. Postal Service, the mail is going to get through one way or the other. Maybe it'll be mangled by the time you get it, but it's going to get through.
Well, they've also added, to that inside the network, so whatever you're connected to, like I'm at a university, and they had contacted us a while ago about, how would you like to have a server on your site, pay us X amount of money, dollars, and you can put something inside your network so it's not going to the outside network. And that keeps the bandwidth and the pipe, from the university to the outside world still open and let students go and pull the content from the on-campus server. Well, we didn't go that route, but those things like that they added too. It's like, how can we get this content to you without it buffering as much? So, and without, clogging up other pipes elsewhere.
And there were a lot of solutions like that at NAB. Maybe not getting as much headlines as ATSC3 and SMPTE 2110 and all that, but I ran into a lot of companies that were showing me some really cool bells and whistles in their encoders. And the price of encoders is coming down. They're becoming more powerful. And as opposed to an encoder that just basically sends out a stream and doesn't know what happens at the other end, some of these encoders are actually polling the network and saying, can you sustain 20 megabits a second? Guess not. All right, I'll start sending you 10. Or I'll drop the resolution or whatever I have to do. So that's an important part of it too. That's the quality of service issue. What's the quality of service? Well, that the customer's video stream doesn't get interrupted. Beyond that, you have a lot of leeway. Okay, so if we can play with the resolution, maybe drop it a little bit, or we can drop the frame rate a little bit, then pick it up again when we have to. Yeah, that's fine. That's all cool. Just make sure you don't drop the stream.
Question back here?
Yep.
Yeah, what's the vision? What do you think get a sense of the vision of how all these devices are going to connect? You were talking about the good old BNC connectors worked for many years. What do you think the future of interfaces connectivity is?
In the home?
Between devices in a plant.
Probably. Pete, is that one of yours?
Oh, you mean in the facility?
Yeah.
Oh, in a facility.
More is going fiber and fiber. At least I see it.
It
More
should go
going
to fiber. It should all go to fiber.
It's the only thing that's really going to support the data rates over the distances that we need. I mean, I don't know how much farther they can stretch copper.
We're starting to see 12G SDI. And here, people talking about 24G and 48G SDI. But that's got to be over optical fiber.
Yeah, and we built a 100 gig backbone downtown there, and it's all fiber. It's all fiber. I don't have a single strand of coax going through for any of my core distribution.
The 8K Sharp cameras use 4 12G SDI copper cables to get the data off the camera to wherever it's going. They're not really long cables, but to go to whatever the recording media is or to whatever the streaming interface is. So it isn't quite dead yet. The problem at the cable manufacturers, and Steve Lampin, you might remember, did this great presentation at NAB one year about this, excuse me, is there's a signal and noise specification for SDI. He says, I can make you a 12G SDI cable, but I got to play with the signal and noise specification. I got to jigger it a little bit because I can't hit it for what it is for 3G.
Okay. Oh. John.
These local broadcasts, well, right now everything is still 1080. How do you think they're going to move to 4K soon? Do you think everything's going to stay 1080 for a much longer time?
Oh, I think it'll be at 1080 for a while. You have some people out there that are lobbying for HDR 1080. Looks beautiful. Because keep in mind that the TVs now have these very inexpensive chips in them that do a wonderful job of scaling 1920 by 1080 up to 3840 by 2160, because it's a linear, doubling vertical, doubling horizontal. So if you've ever had a chance to talk to John Humphreys at Hitachi, he's a big advocate for this, and he's done tests of it. So you master your content in whatever resolution you want, maybe preferably 4K. Then you down convert it to 2K, but you send it out as HDR. It looks beautiful. I mean, anybody will see the difference. They might not notice that it's slightly lower resolution, but they'll notice the difference. And if the content was mastered at 4K, down converting at 2K, it looks better than if it was mastered at 2K, because you have more photo sites in the camera, so you get actually a better looking 1080p picture. So if you add HDR to that, well, that's a very practical implementation of HDR for broadcast.
And it's better depth of field too. If you capture it with a higher, the 4K, 8K, you get better depth of field when you bring it down there.
Right, and if you're multiplexing, if you're muxing, and everybody's going to be muxing now because you're going to be doing it on 28, I got to ask you how many things you're going to have in your mux. I know NBC's doing it on 36 with WNJU. But, if somebody's looking at that and saying, well, 4K, that's an awful lot of stuff in there, but if I can just do 1080p and I can add metadata to do HDR, yeah, I can live with that. Or maybe just HLG and I can live with that.
We have time for a couple more questions. You had one.
I had one.
Yep.
I work for the Philadelphia Phillies, and one of the things that has really started to hurt us is we have all these suites and all these TVs, and people are driving us nuts with the complaints that why is it taking so long for the field action to show up on my TV? So the question I have is, how much thought do you guys put into latency from the time that it actually happens till the time someone's seeing it? In the world of sports, that's big time. I mean, seriously, I can't even tell you. I mean, why is it such a delay? It wasn't like that in the old days. Like, well, because a BNC, it happens here, it comes out there in real time. But when you're doing an IP design, it's murder for some of us end users who need it to be. But some of them actually do that approach.
Well,
built-in 5-second replay.
Where's the source video? Where's the source video originating from?
Yeah.
We're talking about.
We need most of our games locally are on Comcast Sportsnet. We need to take it off air with commercials. We can't. While we have the means to take the shot directly and pump it out, we don't do that because for safety's sake. But now we've been working with the engineers at Comcast Sportsnet to try to get something closer to real time. But for a while there that season, we had like a 13-second delay. It was murder.
13.
And that's really.
Well, that's a long cop.
Do you guys think about that? How long does it actually take to get from the actual to the television? Is that something you guys think?
That's a special use, though. But I see your point on there. You're watching the game, you're looking up there.
But when it comes to sports,
But there's an advantage to that. If you're standing at the hot dog stand, and a couple of years ago, Chase Utley had an inside the park home run, and everybody yelling, I ran inside and looked at the television, and I saw the whole thing all over again. So I had to wait like 15 seconds. Up there it is.
but it's interesting too. Now, I used to work at the center when we tried to synchronize our feeds with WIP radio. A lot of people like to listen to the radio feed with the television, and that's another set of complaints. Why is the radio pretty much close to real time? And then, so it's in my world, IP sounds really cool and everything, but the delay is just.
So I don't think that's because of the IP world. I think especially your 13 seconds, they were probably doing a couple different satellite uplinks up and down.
Around the country now.
Yeah.
It comes back with commercials.
That's more about the path than, because it had to go up on a bird, come back down. I'm guessing it went. I don't know if that went out west or just up to Inglewood Cliffs and then back. I mean, that's just straight travel time. If it was pure IP, all fiber, and didn't ever had to go up, you'd probably cut that by at least a third.
Well, I believe that's what the guys down at the center did.
Actually, I think I can solve your problem. I think you need to put an encoder in Inglewood Cliffs that just gives you that feed right back to, with very low latency.
But I believe the Phillies were willing to pay for that.
Yeah.
Given the number of complaints we get.
Or like he was saying, what they did at Miller's University with having two separate feeds, having one that.
Well, like you said, just to protect themselves, they have to make sure it's the air feed and not something that's coming out of the truck. But I think if it could be arranged, you could put a real fast, low latency encoder in Inglewood Cliffs and have a dedicated decoder in your facility.
Over an optical
That would
fiber.
probably save.
Yeah. If there was only a company that could provide us the bandwidth.
On a side note, when NBC 10 airs the games, which we do on occasion, we'll switch to the off-air feed. It's faster. The one coming in from Comcast is way late. So we actually will take it. We have an antenna on the roof, and we'll demodulate it and pump it out through one of our in-house channels.
Right, we were talking about a 1.5-second latency there.
Yeah.
Yeah.
So your off-air feed is one.
That's a much simpler production chain.
Exactly, because I mean, when we encode it, we're sending it. We're sending over a fiber to Comcast. They have to do their thing and then put it through their system. So there's latency that they're introducing. Obviously our over-the-air is the quickest, right? It's the same source. They're going out to everything at the same time. They're hitting the transmitter. I'm giving it to Comcast. I'm giving it to Direct Dish, and actually one of our confidence monitors here. We've got all the MVPDs that we feed it to, and you can see over the, obviously the signal coming in from Dry Creek is ahead of the curve. Then the over-the-air, then Comcast, and then way down the chain, our Dish is actually quicker than Direct. Direct is by far the slowest. I don't know what extra they're doing.
Direct is actually showing the game from the day before, I think.
I think so. Yeah. Yeah, and then Verizon is somewhere in the middle. AT&T doesn't exist here, so we don't see them. No Uverse, but I would venture to guess that Uverse would probably be pretty pokey as well. Probably somewhere between just before the Directs and Dishes of the world.
Isn't that gone now, Uverse? I thought they shut that down.
They're still kicking, and not in this market, but in
Right.
a lot of markets.
One more question. All right.
We manufacturers had talked about the fact that it seems to be less people at NAB this year, and
Yep.
people are questioning, is NAB going to be around?
Raymond, they were all in the South Hall.
I believe you.
Yeah. You couldn't walk through there.
But even the numbers, the NAB numbers will go down. I personally think NAB or an NAB type of show is definitely important. As for manufacturers, yes, we like to see people out there. People like you go and see a lot of different technical displays of meetings. So just curious, when you go as a female, do you feel like it goes down?
I also heard that it was a lot more of the streaming DIYers and not as many of the big broadcasts. Is that true too?
I think it was treading water this year. That was my impression of it. It was actually one of the most mundane NABs I've been to in a long time. There really was very little in the way of like, holy cow, or wow, look at that, that was amazing. There were a few things here and there, but you really had to look for them. But overall, it was kind of like, it was. If I missed it this year, I wouldn't feel like I had missed a lot.
The show felt a lot like last year. I think you're right. It was just kind of treading water.
Yeah.
The biggest, wow, it really wasn't a wow, but one of the most interesting things, I think the show is going to start to morph. I think it's going to start to change, and I'm really curious how some of the little, widget hardware manufacturers are going to make it. I think the show is going to start to turn into more of a software. The most interesting thing for me was Cisco's kind of outlook on dominating the industry, right? But this year they came with a better argument or more to show than in previous years. They always want to dominate everything and ultimately take over the world.
This is the same people that bought the flip camera. Remember that for hundreds of millions of dollars and then shut it down.
But they're starting to come up with a compelling case for we can do this all on software.
And they can.
And they can. So it's going to be interesting to see how over the next probably 5 years or so how the show changes and who sticks around, who doesn't, and how it morphs.
A lot of the show this year was just people putting up a wall with all their stuff on it. You didn't see as many private room demonstrations or theaters to wow you or anything like that. And you probably noticed some of the manufacturers' booths have been getting smaller and smaller and smaller. So I don't want to necessarily single them out, but it wasn't that many years ago. Panasonic had the entire mezzanine level from one end to the other. Now they have about a third of it.
Yeah, in fact, I looked at Panasonic. We used to make appointments to start at one end, half an hour later, the next people see me, I was at the other end. It's such a long walk.
They're all doing it. They're all.
I know you can do it in 10 minutes.
they're all retrenching, right-sizing, and the bulk of the traffic was in the upper and lower south halls, and that's where you had the companies doing streaming, you know, codecs, the AV1 people, the open source codec and all that. It was just a madhouse over there, but the North Hall and Central Hall, crickets.
I also noticed that in broadcasters, cable companies are sending less and less people. It used to be NBC,
Yeah.
CBS would live for 2 weeks in Las Vegas at offices in Hilton, and they would come in with flags so that all their people could follow them. And now you get 3 or 4 young people saying, so-and-so told me to see you. He couldn't come to see you.
I think the show, it will evolve. I mean, just the fact that, again, the upper and lower south hall was so jammed up proves that there is value going to the show. It's just that the nature of it, it's what Tony just said. It's going to be more an emphasis on software, less an emphasis on hardware. There's not a lot of money in the hardware anymore, and a lot of the hardware is getting really, really inexpensive. So you can't justify building an enormous booth if you're selling products for hundreds of dollars. You just can't do it.
Well, the whole industry is changing. I mean, we're going over the IP world. We're going over to software based. We're going to plugins, and you know that the whole industry is changing. So as the industry morphs, NAB is going to have to morph just to remain current with it and bring people out. There's the NAB New York now that bringing people out. You know,
and that show's growing every year.
Yeah,
getting bigger every year.
So that you know that what Satcom and something else combined. CCW. Thank you. You know, and now AES is part of it and trying to grow it and bring people out here. I mean, for years, a lot of people from DC and the government didn't, you know, go out to NAB. You know, they took away, you know, the NAB down in Orlando, you know, years and years ago. So that's bringing it back to New York. Maybe that'll help drive people going, oh, I'll do the New York show, then I'll do the Vegas show. You know?
SMPTE used to be a big show years ago.
The what?
Many years ago, SMPTE was a big show in New York. 15,000 attendees. Now, can't get anywhere near that.
Right. Well, I'm not going to go down there tonight, but yeah, I mean that's a whole other thing.
Well,
the whole industry's changing.
All the trade
People,
shows are
yeah.
seeing it. CES is going to see it too. They're all going to see it because of a couple things. Number one, everything is moving to software-based switching, signal distribution, and management and control. And secondly, hardware is becoming really, really cheap. And it's hard to justify building an enormous booth to sell cheap hardware. Unless you're at CES and you're selling jeweled iPhone cases. Those guys go crazy out there. But that's really what you can clearly see this over the years. That's the trend. How it impacts a trade show, it's really hard to say. But some manufacturers down the road may say, there's no reason for us to be there.
You can research anything on the internet.
Yes.
It's a lot cheaper to go on to Vegas.
Yep, exactly.
But it's all about content. At the base layer, it's all about content and how people are going to get content. And that's changing. The industry's changing. So the trade shows are going to have to change too. So I'm going to... Yeah,
I'd like
go
to
ahead.
make some comment here. Question for you, Mark, and our student, in fact, room full of experts. I'm on the board of directors for SMPTE, and our mission is to change the membership. We're trying to get 30% of membership under the age of 30, and we're nowhere near that. So with that said, I put my money where my mouth is. I'm involved with STEM events, national, regional, whatever, for middle school, high school, trying to tell kids. I speak at universities. I have other people doing the same thing. But what the story is, the creative is the obvious part of this industry. Everybody gets it. I mean, I want to be a next James Cameron. I want to be a director. I want to be an editor. We have enough editors. I want to be a camera person, whatever. Every young person gets that. What they do not get, there is a technology and a business that makes that all happen. It's invisible. And the fact of it is, what I tell students, I tell everybody, to be successful in this industry, you must embrace all three. You can't say, oh, I'm a creative, I don't worry about the business or the technology. You must embrace all three. If you do, you can do anything. You can take your career wherever it's going to go to next, and wherever it is today, it's going to be someplace else different. With that said, how do we act locally, think globally, change that? What do we do to make this